business items to discuss tonight that are pretty important, and we've got a really exciting program, as you all can see up. That we want to make sure we maximize Bob's time to tell us about. So with that, we'll get the introductions out of the way real quick. I'll start. I'm Tim, AG4RZ. Stephen here.
AG4JW.
John, M0KTY.
Henry, W2GZO.
Da did it, da da da, da did I did. Da da da, did it did da, da da did I did it, da da did it.
I'm just ready to
A4, DBS.
Woody,
Don, WS4NC, and renewals finally went out in March. We'll just pass them to Henry first, and then I'll get them. Thank you.
I'll go with something he wants to tell us about here.
We had a club member who applied to the FCC for an upgrade to his call, and he walked in a couple of years ago. This was in the newsletter, and I looked at him and go, "You dog! There's a very, very, very famous call for those of us who go back more than just a few years. AC4YN Tibet, and on eBay recently, one of the QSL cards sold in 1937. This is not it. This is a reproduction. It brought $2,150. Is that right? Jeff is now the proud holder of that call, and it was just assigned sequentially, you lucky dog. And I'm going to present him with a probably not quite legal copy of the 1937 card tonight, so he can put that to his collection.
I'll put it along with this.
Alright, it looks like our treasurer is busy over there, so we can leave him for a minute. Alright, Dale's not down here yet, so we'll bypass him and we'll go to Jim for experience. The long way around.
Head on, turn to the right. Okay, we did last month, we put out the first time with the Pilot Mountain Payback Marathon. It worked great. Thank everybody that was involved. We weren't there to miss an interesting activity. This is a foot race, so things a little different from the bike outfit we used to do. We convinced them that the race director might be able to use the sag wagon. They agreed. 2 days before the race, somebody told them the sag wagon. So most of the runners who needed to drop out and take one time of the night, one of our guys did actually sag somebody down to the starting line. There was another incident that I was not handled by radio, but got a word of mouth from the other fellows. One of the runners got totally lost and came up and picked up on a state trooper and ran down the third US 52. The cop brought him back to the gate, the lower part of the park, and he ran on in on his helmet. And then when the official timers closed down, 6 hours after starting time, we still had one body missing in action. We assumed he just left the course. Because most of us here could have made a half marathon in 6 hours. Next event, for sure, there's a possibility of doing something with the details as we get closer, but, pulled out the sheets from last year, we used about 12 people in various capacities, sag wagons, rest stops, net control, and because we've got the, road wings working on this, we then put relay stations, equipped with both CD and computers, on Pilot Mountain, on Sorrowtown. So keep that date in mind, and I'll be asking for volunteers with it. Again, thanks to everybody who's been helping the areas so far.
Thank you, Jim. All right, we'll hear from Henry now.
Okay, thanks to everybody who sent in your stuff already. I think I have about 15, 16 or so renewals at the post office today. So we got a couple in here. Treasury, until just a few minutes ago, which was kind of sad, but we knew that was coming. We did have a major expenditure in the last 30 days. Dale will fill you in more about that. But I'll just tell you that we basically have approved the purchase of a new heater for several that we've got. So I will let Dale fill you all the details. That's taken care of. That was $1,445. Brought us down to $594.73. We're putting in, as of right now, about $463. So 1,057.73, which is much more comfortable. Equipment liquidation we're doing the next 6 days, and it's interesting too. So thanks, man. Just reserved Happy Park last week. All right, so we got a slide. I forgot about that.
We got a slide, all right.
Has everybody signed the?
Yeah, has everybody signed the roster, sign-in sheet? David, just see me after. All right, and with that, I guess we'll get to the program. I sat down and tried to figure out how to introduce this guy. And a lot of things came to mind because I've known Bob for quite a long time, and there are a lot of stories I could tell about him.
Oh my God.
and there's a lot of stories he can tell about me. So knowing that, the smart thing to do is probably just tell you who he is, what he represents, and what he's going to talk to us about. This is Bob Gusick. He's with FabLocker, the local hackerspace here in Winston-Salem. Hackerspace is basically a space where guys come together, and just like I wrote in the article, you know, different backgrounds, different ideas, different interests, different talents. They pull their talents to build cool stuff and just, you know, do whatever they want to do, basically. Bob's going to talk to us tonight about 3D printing specifically, and expand a little on the history of 3D printing, how it works, and that sort of thing, and probably get a little bit into the space as well. So with that, Bob, it's yours. This is mine.
But you have to pass it around.
Yes, I will pass it around. And there are souvenirs. This is not one of them. If I don't get this back, the souvenirs don't get passed out.
No, we can just print another one. No big deal. Hello, everybody. Thank you for the wonderful introduction from Tim. He didn't go into it, but we've known each other for a long time through Jeeps. We used to drive Jeeps all over the place, both legally and illegally. But I've known Tim for a long time, flying RC planes, Jeeps, and all sorts of stuff. Like you mentioned, I'm a member of the FabLocker hackerspace in Winston-Salem. And what we do is we do anything to do with electronics, robotics, computer programming, manufacturing, RC stuff, basically anything we want to play around with. One of the big things that we work on are what's called a 3D printer. The more official name for them is called a RepRap, which stands for Self-Replicating Rapid Prototyping. And with that, let me go into the quick history of RepRaps and printers, and then I'll give you a quick rundown of my printer here that I brought in, and then take questions. So like I said, the RepRaps are called Self-Replicating Rapid Prototypers for 3D printers. The origins started probably around 1990 or so, and various hobbyists and other groups were building 3D printers using various different technologies. Everything from what this printer uses called fuse deposition. I can't remember what the last one was. But basically it builds it up layer by layer with plastic. There's other ones that have a big vat of a powdered plastic, and they'll either use a laser or they'll ooze out some epoxy to fix it in place, and then it lowers it down and puts another layer of powder over it, and it builds it up that way, and then you blow away all the extra powder. But the one problem with this technology is very expensive. Most 3D printers start around $25,000 and go up to millions of dollars. A guy in Bath, England, called Adrian Bauer, wanted to make a open source version of this that a hobbyist could do, that was affordable and was reproducible, so it could spread all around the world without a whole big either commercial process behind it, and people could enhance it and improve it as they built it. So he started in 2004 in the Bath, England, and he worked on it for about 4 years and finally got the first model working. The first one was called Darwin, and on May 29th they had their first successful replication. You can see here on the left you've got the parent. That's the one they built from scratch. They basically used the CNC machine to make the parts for it. But then all the parts for the child, the plastic pieces, they actually printed on the one on the left, and then they assembled the one on the right. And after they had it assembled, it took them about 5 minutes, and it was starting to print other parts for another one. And from that point on, they just started spreading out, and they published how to make, if you have the plastic parts, how you can make one. And it went off from there. Vic Oliver on the right there, he helped with a lot of electronics to get the first one running. The RepRap basic guidelines and principles that Adrian wanted was that 50% of the RepRap should be able to be created by another machine. The balance of the parts should be very cheap and easily available most anywhere in the world. And it should always be open source and available to others in the community. One of the big advantages of this is you get people like us in Winston-Salem who are constantly tweaking it and improving it. And we upload the changes and improvements we have to the main RepRap site, and we share it with everybody. So these machines are constantly getting upgraded and improved. And you notice the first one I showed you, the picture of the Mendel, you can see it's a square-shaped machine. And this one's more triangular shaped. This is the third variation of this design. And there's already 3 other variations after this one. One uses extruded aluminum, another one uses acrylic as its base. But now that we've got so many people in the community hacking on these and improving it and enhancing it, the designs are just, you almost can't keep up with how many new designs are coming. Another thing, there's no restriction from taking this design and making a variant, like I said, either giving it back to the community, or you could actually take this design and make your own commercial one that you could sell and support yourself. Because not everybody is willing to spend the time to find all the parts and assemble the electronics and so forth. So you can get anywhere from a kit with all the parts to build a standard. This one's called a Prusa, named after Joseph Prusa in Czechoslovakia, who came up with the majority of this design. Or you can get completed kits for different variants, all the way up to fully assembled and calibrated machine ready to go. You may have seen on the news something called Replicator. It's a big version of a 3D printer that recently came out from MakerBot, and that's the only way they're selling it. They're selling fully assembled, but the price, you're talking $1,500. And the comparable commercial printer, I think the cheapest is around $8,000, and it doesn't print the same quality as these home built ones do after all these years. So how does it work? What does it do? Basically, it's like a computer-controlled hot glue gun, but instead of using hot glue, we're using plastic. You can see the big roll of plastic on the back of mine. And what it does is it feeds the plastic into a nozzle, like a hot glue gun nozzle, and it comes out the end and it moves it around and builds up layers for whatever part you want. Objects are built up layer by layer. There's quite a few designs available out there for people that have these printers and people that are just interested in it. We've got students in colleges. There's actually some courses in colleges that are making a requirement that you design an object that's going to be 3D printed by someone in the 3D community. So we have students that are designing objects, and they say, I don't have a printer, can you print this and tell me what it looks like? And I'll show you the site where we get most of our designs from. And someone will print it out, they'll take a picture of it and say, hey, this is how it came out good, or this is what you need to change to make it a better, print out better. There's a lot of different variations of software that's available for both controlling the printer and creating the designs and doing what's called slicing. You take basically a 3D object from like the CAD program, and then you run it through a program called a slicer. And what it does is it takes the object and literally slices it so that one of these printers can print it. And it generates all the commands that the printer understands to build it up layer by layer. And you have control over the height of the layers. You have control over how thick the wall should be and how much plastic should be used to fill in the center areas. So you have a lot of control over how these objects get designed. For example, a little statue like this, it doesn't require a lot of strength. So I just did a 10% infill on this. So it's pretty much almost hollow. Whereas a structural piece for one of the printers, we usually run about 50 or 60% infill for the also some variation in the types of plastic you use. We either use PLA, which is polylactic acetone, which is actually a sugar and cornstarch-based plastic, or we use ABS, which is traditional plastic in Lego blocks. The ABS has a little bit more flexibility, and it's a little bit stronger than the PLA. But it does shrink and expand as it's heated and cooled. So it can be kind of problematic if you're making pieces that fit together. The PLA is biodegradable. It's much stiffer, but when it heats and cools down, it doesn't change its size. So it's very dimensionally stable. And it also doesn't give off the fumes that it does. So how do you get one? The most common way is to find someone locally who has a printer who's willing to print you some parts. So once you have the parts, that's pretty much half of the machine. The other half is what we call the vitamins, which is the electronics, the power supply, the motors, the belts, and so forth. And generally, depending on how fancy you want to get, you can go anywhere. The lower end, you can build one for about, I think, $425 is the low end. And a fancier one, you can spend like $800 for lots of bells and whistles. This one up here was about $600 because I upgraded a couple of things, but I didn't go crazy with the blade. Another way is, like I said, you can buy parts online. There's various websites. If you don't have someone locally that can print you the parts, a lot of us would print the parts and sell them on eBay. And then, again, you go buy the vitamins. The other way you can do it is the same way they built the very first one. And you build what's called a rep strap. And basically you buy the electronic parts, the motors and so forth. Excuse me. And what you do is you build pretty much a CNC machine. And that can cut out pieces from either wood or HDPE or ABS if you buy ABS sheet. And then you can use those pieces to make one of these printers. And then once you've got this, you can take all the electronics you had on the rep strap and install it on your printer. And then from there on, now you can print anything you need, regular parts. The last way is you can buy one of the various kits. There's everything from people like me who source all the parts, get all the parts together and package it up in a kit, and we sell it on eBay. Or another site, there's also commercial kits where you can buy all the parts. People that started companies and do nothing but sell these rep kits. Or, like I said, you can buy a pre-built one. It's all set up, it's all built, pre-calibrated, ready to run. Of course, the prices vary. From doing it yourself, you're going to get out the cheapest, all the way up to the pre-built one, you're going to pay more. But you don't have to worry about building it. So what can you make with a 3D printer? For the most part, anything that you can create with a 3D modeling program, like 123D, Autodesk, or Blender, or Google SketchUp, you can print on your 3D printer. Big limitations are overhangs. You can only print at about a 45-degree angle in the open air. But you can do what's called support. Your slicing program can build up little support structures so you can print things at 90 degrees or even more acute angles. Like I mentioned, we use two types of materials, mostly PLA and ABS. And there's generally two sizes right now of the material we use. 3mm, which is what we originally started with, and 1.75mm, which is thinner. And basically the big difference is how hard it is to push the plastic out. With the 1.75, there's a little less pressure, and there's a certain design that actually feeds the plastic off the machine, and then it pushes it in just on the exterior, so there's no motors on it. And that's generally what that thinner download for free. A lot of hobbyists upload the designs. For example, that knob that is going around right now, someone needed a knob for the radio, so they designed it and then uploaded it. So now Tim has a fancy new clear knob.
When did we get to that?
Yeah.
Are you kidding with that?
Yeah, I know where it's at. Oh, he hasn't got it back. He knows where it is though. And this website was actually started by one of the commercial companies who started selling one of the first commercial kits called MakerBot. Here's some of the major links regarding 3D printing. The first one is reprap.org, and that's a wiki for the original designers. It has all the documentation. It actually has the designs for all the different versions that have been built over the years. And it's got a lot of references on how to fix them if things go wrong and rebuild. MakerBot.com is one of the first commercial vendors, and they came up with a design called the Cupcake. It was their first design. It was fairly small. It was about 60 millimeters by 60 millimeters by 80 millimeters. But like I said, they just came out with a larger one called Replicator. They're really good designs, but you do pay a little premium. MakerGear.com, they're another vendor selling a standard design with some enhancements. So instead of having to build it all yourself, you can go there and get all the parts from them. And they sell kits and fully assembled machines. Ultimachine.com is one of the major vendors for getting the components, parts, and also the plastic that we use, which we tend to go through quite a bit. 3D printer stuff also sells a lot of plastic, a lot of different colors and different sizes, which is very nice. And of course, the website for our group, the fablocker.org. And like I said, we're a hackerspace. We have offices we rent right off Brookstown Avenue. And we have official meetings every Monday and Thursday right now. Mondays are our open house nights, and Thursday are our printer building nights. Right now we've got 7 printers that various members of the building include. And that's the end of the slideshow. I've got my printer up here set up, and we printed Tim's knob. We're going to print a couple of other things up here. Are there any questions? Yeah.
I didn't hear you looking for a complete
A completed machine generally is about $1,000, and it can go up to $2,000 depending on who you're getting it from. A lot of the commercial vendors, what they'll do is they'll take the basic design and they'll use upgraded parts in it, and they may tweak the design to make it a little bit more reliable. Not that there's any issue with it, but people that buy it generally just want to buy them as well. They don't want to have to tweak it.
That knob that you made, Tim, can you drill and tap it on? You're gonna have to set that somewhere in the shaft.
Well, when you see it, just find out the sort of design for that.
Yeah, it's designed.
I saw the hole in it, but I'm just wondering, would you have to reinforce it? What's the tensile strength?
Oh, it's plenty strong. All the bolts on this, very few, there's a couple of them use nut traps, but most of them are self-threading. So we thread right into the plastic. Oh.
You know, how strong it is. It's a pretty picture of the second generation of this design.
For a 5-pound roll of ABS, it runs about $75. A 5-pound roll of PLA is about $65. And yeah, 1 5-pound roll will be enough to make parts for 5 machines with a little bit left over.
Can you make chess pieces?
Yes, you can make. I'm trying to remember. I think they made 218 chess pieces with 1 5-pound roll of plastic, and that's full-size chess pieces. They basically set up one of the machines. It had a conveyor belt that would automatically take parts off, and they just let it run for like 3 days and use up the plastic.
Now, would you be able to get this sophisticated enough that takes 3
absolutely. That's something I printed on there. And like I said, all these parts, with nut traps and overhangs are all printed on these machines. Absolutely, yeah. This right here, 440, you can probably just use the plastic and make it a little bit smaller and let it self-thread. This, for example, is a watering spout that I made for my mom. And you can see it's got the holes in the bottom, and then it's got the threading in the top that was just printed right into it for a 2-liter bottle. Or absolutely. Yeah, that's where what you want to do is you want to take the infill setting, because it's kind of hard to see, but I'll pass this around too. As it's printing, it's creating a little thin plastic line, which is generally, for my nozzle, it's about 0.3 or 0.4 millimeters wide. And you can control the setting of how much plastic infill should be. And I'll pass this around. You're welcome to try and break it. This is only 40% infill. If you want it solid, you can print it solid. I mean, it's basically the same strength as a Lego block. We generally, if you try and break one of these pieces, that we make for the printer with about 40% infill, you're going to need a pair of pliers to break it. Exactly. CNC is subtractive manufacturing, and this is additive manufacturing. Right. CNC is a little bit faster, because like I said, depending on what quality you want out of this, you can set the layer height anywhere. This one will do down to 0.1 millimeter, and basically you cannot see any of the ridges on the side. It becomes almost totally smooth when it's printed out. And you can run it up to, this nozzle is 0.5, so that's the highest thickness you can make is a 0.5 millimeter layer.
Is this on YouTube? Can you see it work?
There is all, oh, you can see this one work if you like.
I was hoping you'd do that.
Oh, yeah.
Could be to make another knob.
Here, let's make another. Anybody else need another knob? Yes. Yes and no. What you can do with this one, since this is a single nozzle extruder, when you get your G-code, which is what drives this machine and what it uses for its instructions, you can actually put pauses in there and tell it to pause, and then you can change out the colors on my machine. Now there is that new machine from MakerBot that runs about $1,800. That is one of the first commercial machines that has built-in support for dual nozzle extrusion. So you can have 2 different colors printing at the exact same time. So and the software is made to take that into account. So you tell it you basically take 2 objects and say, this is going to be the color number 1, this is going to be color number 2, and it meshes them together, and then it tells the machine to print the appropriate color plastic. It's a little bit of both. There's the controller board. There's several different versions of the electronics. The most common one is an Arduino board, Arduino Mega 2560, with the daughter board on top of it. And then there's like 4 or 5 other very common versions. This one's called the Sanguino Lulu, which is a one-board solution. Doesn't have a daughter board, but it's basically an Arduino chip. And you burn the firmware onto your microcontroller. And then from the, let me pull that up on my laptop. And I'll show you how we go, what happens when you take an object from 3D design all the way through. So this is what we start with. In fact, let's start with finished here now here. So this is called an STL file, which we get from the CAD program. here you can see this is the cat. So you can see here's the screw hole, and you can see there's the hole for the shaft. Now, when they designed this, they didn't try and get this circular surface real smooth, but you can make a perfectly round object with this. So this is what we start with, which is called the stereolithography file. And what I do is we use this program, it's all open source program, and we use this program called Slicer, and this has all the settings that I had to generate the command file for the printer. So I tell it what scale, whether it should be rotated, to get it to fit, because some things won't fit right unless we rotate it. I can print multiple copies at a time. So something like, if I needed like 4 of these knobs, I could say print 2 on X, 2 on Y. Say how far the distance is between the copies. And then here's where I set the fill density, how much of it should be filled in. I tell it how many solid layers should be on the top and the bottom. So right now I've got it set for 2, so that means it's going to be a solid for 0.6 millimeters all the way around the object. And these are some control parameters for as it's extruding, as it moves around, as it's printing. If you just kept printing all the time and you just stop extruding and then try to move someplace else, there's enough pressure inside the nozzle, the plastic will keep oozing out after you started to move someplace else. You can get these funny stringers and blobs on the object. So we use retraction, and what happens is as it's printing, you'll see when it's printing earlier, you can come up. When it comes to a stopping point, all of a sudden it'll spin backwards real quick. And what it's doing is it's creating negative pressure to pull the plastic up so it'll stop flowing. It'll move to another spot, and then it'll spin forward real fast, so it's ready to start extruding plastic. And the guy who writes this, he's doing this totally for free. Works totally on donation. This is the cooling section where you can control. If you have a very small object and you're sitting there building up layers, it doesn't give it enough time to cool before it prints the next layer. So what'll happen is it'll start out real nice and look real nice and round or square, and then as it gets higher, it starts getting blobby because you're trying to print on hot plastic on top of hot plastic. So this is a new feature that tells it to slow down when it doesn't have enough to print, so it allows it time to cool off. And here's where I tell it where I want the object centered on the print bed. I tell it the size of my nozzle, what kind of software I'm using, and how fast it should run in various times. And here I also tell it to print the first layer hotter so it'll stick to the plate. And then I tell it some commands when it first starts, it goes to home. And then when it's finished, it cuts everything off and pulls the Y carriers all the way back and then turns all the motors off so they won't get hot. So all I do is I do slice, I pick that STL, and then after a few minutes it will generate the G-code file. And then once I have the G-code file, I'm not sure if this is going to work because I've never tried it while I was projecting too. This is the interface program for the printer. So what I do is I connect to the printer and it gives me all the controls to move the print head left and right, back and forth. And then what I do is I say I want to load up one of these files. We load up this knob here. And then what it'll do is it'll take a look at the object and it knows how much it's got to print, and it tells you how much filament it's going to use. This is just a little bit over half a meter of filament. It tells you the size of it and roughly how many. Well, it tells you exactly how many layers, and then estimating how long it's going to take to print. loaded it, and I was connected to the printer, I just tell it to print, and it will start sending all these decode commands from this file, one at a time, to the printer. And then the printer does whatever it tells it to do in the decode file. And this is also open source. This is actually just a script. It's not even a real program, it's just a Python script. Any other questions? Yes. The ABS starts melting at about 190 degrees Celsius. It'll start degrading around 250 degrees Celsius. The ABS just starts getting really bubbly. PLA is a lot lower temperature, around 150 degrees Celsius. Depending on what version of PLA, there's quite a few different versions. And when you order it, they'll tell you what version they have and a sheet describing the temperature and when it goes to liquid state. The upper limit for PLA is usually about 195. And at that point, PLA starts actually turning brown because it's mostly sugar and cornstarch. I honestly haven't tried or looked at what the lower limits. A good guide is pretty much anything that a Lego block will do because it's the ABS is Lego plastic. And there's actually quite a few designs up on Thingiverse. Let me show you that real quick. This is the site I was telling you about that has a lot of different objects that you can download. And here's that crank dial. Are you happy with that? Okay. But basically, it's right now they got about 500,000 objects on there that you can download the files for. Some of them are just the design files that the printer reads. Other ones include the actual 3D modeling software files. For example, a very popular program that everyone uses is called OpenSCAD. This is a design I made because I had some problems with my nozzle overheating. So what I did was I designed a cooling fan that I can mount on the side of my printer. And I just built this up from cylinders and squares and subtracted out the holes for the screw mounts. And if you see on this printer that green object just underneath the exterior, that's this piece that I designed and built for my printer. And I uploaded it, the design file and the STL file that you can run the printer from, up to Thingiverse, and probably about 25 other people saw it and said, hey, this is great, this will fix something I'm having trouble with. They've downloaded it and printed it, put it on their printer.
I've got multiple questions, but two together, has anybody done anything like lost wax casting where you make the part and then you're
Yes.
smiling?
Yes.
And can you do something like with wax?
We actually do that at Fab Locker.
Okay. I'm there.
Generally what we do is for metal casting, we use PLA.
Yeah.
Because it's cornstarch and sugar, we can print the part and then do a sand cast of it with the screws and everything. And then pour the metal right into it, and the metal will vaporize the PLA.
Yeah, okay.
So it's just like lost foam or lost wax casting.
Okay.
There's also, we also do silicone molds of parts. Some of the guys have done we have another group that does security and lock picking, and they, it sounds weird, but we actually have a guy, that's what his work is. He works in security, and he, basically, if you've seen the movie Sneakers, that's what he does. He gets hired by banks to try and test their physical and electronic security. So one of the things he's researched locks and lock picking, and he goes to seminars all over the country and talks about how to pick locks, and test security. So one of the things they wanted to do was they wanted to make a big model of a lock. So what they did was they printed out parts on the printers, and then they created silicone molds from these parts, and then they used urethane to cast the final parts for this lock. So they built a lock that's about that big, and about that tall.
Okay. Well, you mentioned extruded aluminum. That
Yes.
got me curious. How do you, is the heat involved?
Well, we don't extrude the aluminum on this.
Oh,
It's
okay.
basically a structural piece. If you see up here, these pieces right here, these are just threaded rocks. As part of the vitamins, and you notice we got nuts all over the place. And basically what you have to do is you have to either cut the rods yourself to very specific lengths, and then use a gauge to make sure you've got the right dimensions on everything, and then tighten everything down very carefully. Well, there's a new version called the Mendel Max, because this is a Prusa Mendel. And Mendel is probably pretty much a generic name for all the riprap. We name them after biologists. So what they did was all these places where we're using threaded rod here, and also these printed pieces, they replaced most of it with extruded aluminum. And if I could get on the internet, I could show you, they actually built the first one, and the guy actually set it down on the floor, and he can stand on it, and it doesn't deform or flex. So it's extremely rigid, because you can see that this has a little bit of wobble to it, and if you start printing faster, that's one of the things that can affect your quality and keep you from being able to go so fast.
And again, the one question is the speed. Like print that knob, how long does it take?
It took about 15 minutes. And I'm running generally around 50 millimeters per second on this printer.
I don't know what you call these machines, but they take a very fine point and go along and basically trace an object. And
Yeah.
it occurs to me you could take one of those and have it copy something and I'm sure somebody's thought of this.
Absolutely, there's designs for it on that Thingiverse website.
Okay.
I forget what they're called, but yeah, it's basically a 3-arm link with a probe on it, and you just basically trace all around it. Those are a little bit more expensive and harder to build because you need a lot of accuracy and close tolerances on those arms to get an accurate reading. The more common thing is to use a Kinect from an Xbox 360, and guys have written software that lets you scan an object using a Kinect and create a 3D model from it and be able to print it on here. A lot of the buff stuff on Thingiverse are made from that. There's another group in Germany that has created a 3D scanner using two-step motors, a line laser scanner, and a Logitech webcam. Total price is about $150, and there's a couple of other small, and an Arduino. And it will take a very, very high resolution scan of any object. You set it on the platform, it'll slowly turn the object as the line laser scans over it. And it's comes with free software, and we actually are going to be building one of those at Padlock. Once I finish my other one, I'm building one. Yes. Yes. That's based, a couple ways you can fix that is by going to a thinner layer. When you go to a thinner layer, you get less of that drooping and overhanging because it supports it, because you're going at a finer gradation. Also, if you use a thinner nozzle, you're not printing at 0.5 millimeter wide. Generally, the smallest is 0.25, but the most common is 0.35 millimeter. And that helps a lot with your accuracy. The other, yes. Not a really great example, but this is one of the gears I printed as part of the geared part. Lets you take an object and run it through a script, and it turns the entire object into a series of gears that interlock together. Like I said, it depends on how accurate your printer is and how much time you've taken to set it up to not have any play in it. The Mendelmax, the next version, is what basically everybody's being recommended to build. Because with that extruded aluminum, you eliminate having any kind of adjustability with the nuts, because it's all precisely cut extrusion. So you push them together and bolt them together, and they're always going to be that distance. Plus, the rigidity really helps with accuracy and not having to worry about making sure this is all square. It took me probably about 2 days to build just the triangular frame, making all the adjustments, putting the nuts on, and measuring it over and over again to get it exactly square. One of the examples they have on reprop.org, it's a cube. It's about that big, and it's basically a set of interlocking gears. It's called the brain gear, and it's a test of how accurate your printer is. If you can print this and then take it off your printer and it turns, because basically it's got it's basically a bunch of vertexes with gears on it that all interlock. So you don't have to assemble it or anything. It comes off the printer like that, and you can spin it. And if you've got a good enough printer with enough accuracy, with control of the ooze, and that's a lot where you actually measure. One of the parameters on that slicing program is the diameter of the filament, and that's where you got to be careful. You want to make sure you get good quality filament that is a consistent diameter all the way through. And I actually will. I've got my little tool here. Oh, I hope otherwise there it is. Here it is. Yes. Using my micrometer to measure my filament before I do my slicing, because 0.1 millimeter filament change will make a difference when it moves the extruder and pushes plastic in there on how wide it is and how much dripping you get. So generally what I'll do is I'll measure a spool when I start to use it, when I get about halfway through it and towards the end. And then I'll just re-slice if the values change to get really accurate prints. Honestly, no, I've not. I built this, started in January, and I finished it like the first of February. And pretty much since then, I've been running it 24/7. There was 2 days when I didn't run it. One when I was out of town, and one when I had I had one of my spring trips. Other than that, this has been running 24/7 since then, and I've never had the nozzle down.
What's the nozzle made?
My nozzle is made out of brass, which most of them are. There's some guys who've made them out of aluminum, but I think brass is probably the best because it's the most dimensionally stable and it transfers heat very well. The most common problems I have with my printer is as the filament feeds in here, I've got this stepper motor here, and there's a bolt that's got a bunch of notches in it, and that's what grabs onto the filament and pushes it into the nozzle. And there's a little idler block here with a bearing that sits opposite of it, and what happens is that filament has to fit in that notch, and then the bearing pushes against it. And the most common problem I have is the filament will move, or the filament will stop moving. It's not pressing hard enough, so it grinds a groove into the filament and it'll stop feeding the filament. And I've had that happen probably 3 or 4 times. And again, that depends. PLA is much more likely to shift away from the groove because it's stiffer. ABS is more flexible, so it has a tendency to stay in line much easier. But it needs more pressure so it doesn't cut a notch into it. Yeah, that's the whole point of it. Yeah. Yeah, actually, and I'm using, and you can see up here, these right here, this is this part right here And this is this side right here, and these are parts for Tim's printer that I'm printing for him so he can build his own printer.
Thank you, Bob.
You're welcome.
Now, can you, if you, let's say you're making a chess piece and built about a quarter inch to the bottom, and you said you could set it, could you drop a railroad magnet in there? Something like that?
Yeah, I've heard of somebody, we've got one of the people at our fab locker, just to digress just a little bit, his name's Neil Underwood, and he's one of the 10 administrators for the Worldwide RepRap.org site. He does all the tech support, so he is awesome to have in our group, because we can ask him, hey, mine's doing this, what should I do? He can tell us exactly what to do to fix it. But he has definitely afraid of squirrels. I didn't tell anybody this. So we happened to find a squirrel.
Oh, it's not on the internet either.
Oh, no, never,
No.
never. We happened to find a squirrel on Thingiverse, and we printed out probably I printed about a dozen the first time. A dozen, and I stuck them all around our house. He came in, he's like, Bob! And then someone else brought in some neodymium magnets and said, hey, can we put this in a squirrel? Sure. So we started to print, let it get up high enough where it would cover up the magnet. We stopped it, we pulled out a little bit of the material, dropped the magnet in there, let it finish printing, stuck it. These things are magnetic, if you don't realize it. And we happen to have the same ceiling right over the desk where Neil does a lot of his posts and stuff. So we hung it up on the ceilings. And I happened to come in and I said, Neil, you noticed anything unusual today? He's like, really? You haven't seen anything unusual? He started looking around.
How big were the squirrels?
The squirrels are about that big.
Chipmunks,
Yeah, baby squirrels. And we started printing owls too. So to get rid of the plastic squirrel, you have to have plastic owls. So now, if you come to our space, you'll see, well, right now there's none because people keep taking them because girlfriends and wives, for some reason, like the squirrels and owls. But we keep printing them out and leave them all over the space just because I like them so much. Any other questions? I guess I have one.
Have you seen where the relationship of what you're making with some of the printers in the medical industry?
Yes. In fact, the recently, I think it was about 2 weeks ago, there was a lady in Boston who, through an accident, lost her, was it an accident or yeah, she lost her jaw. Her jawbone got crushed. So they actually printed on a commercial printer a replica of her jawbone. They had x-rays of her jaw. And they built a 3D model of her jawbone and printed out of medical plastic on the printer. And they replaced her jawbone with this plastic, and now she has a jaw, she's able to speak with it. And there's other cases. The medical industry is starting to look at alternatives for what they're currently doing for reconstructive. Yes. Now those, and actually Wake Forest is the first, Baptist Hospital is one of the pioneers in that. They're actually printing kidneys out of, they're not using plastic, they're actually using stem cells and some other techniques, and they're building up, they printed an artificial kidney. And they're looking at building organs like that, using materials that are appropriate that will actually grow after they build the structure.
Yeah, I guess I was trying to say the same relationship between your hobby with the medical and crystal.
There is quite a bit. Some of the guys that do write some of the software for this are involved in both commercial printing and with the medical industry. We actually have a new member that just joined us. He's related to the Center for Design Innovation, which just broke ground in the research triangle, or the research park over there in Winston. And he's very interested in using the printers and the things they're doing for rapid prototyping.
Does it have a self-destruct to become semi-autonomous?
No, we have something that we want to try to print, but Tim is scared.
I'm scared, I'll admit it.
We actually have the head of a T800 that someone actually uploaded, and some of them have already been printed. We haven't heard anything negative yet.
We haven't heard anything positive either.
Yeah, well, no, one guy did post that I've not been,
Yeah, he's still alive.
and I've not been killed by my Terminator that I printed.
So,
There's quite a few people that are building, again, to what you were mentioning about the medical industry, they're using it to build prosthetics. Prosthetics for medical use and prosthetics for the film industry, for building props and so forth. Because you can print something out very quickly on one of these printers compared to traditional manufacturing, which is another huge benefit and is attracting a lot of attention. One of the, I think probably one of the most visible users of this is Airbus and EAS Industries. They do all their prototyping, instead of machining the parts, they actually use a powder printer similar to this, does the same process, builds it up layer by layer to build their prototype parts, check for fit, for the engines they're building, or for linkages for the landing gear.
Now, so this is really a new form of manufacturing, that's basically coming down to, depending on what scale we're building at.
Absolutely. That's why Adrian wanted to build one that was more accessible to the user. It's sort of like the same path that the computer industry took. At first, there was all these computers that were huge. You needed millions of dollars to run them. You needed specialized people to maintain them. But then there was people that wanted to be able to do that in their home. Guys like Apple, IBM, Microsoft, and that's how the home computer industry started. Similar kind of thing. That's what Adrian's vision is. He wanted to take these $75,000 machines and make it accessible to everyone in their home. So you can have one in your home, and if something breaks, you just print out a new one. There's tons of posts on Thingiverse where a guy says, oh, I've got a Honda and I broke the seat latch, went to the dealer, it was $150. So I went and CAD'd it, printed it, cost me 30 cents.
Can you print out a new laptop?
We can't print the screen.
That's a good thing.
We can print the electronics. And there's a lot of research going on in the groups now to actually be able to print out electronic boards.
This was actually reference to your blue screen.
Oh, actually, if you'll notice, this is a Mac, and I did this just to mess with all the guys at the Hackerspace. That's my screensaver.
Hey, that's a good one.
Yeah, I just love that.
You got the PC guys going too.
Hey, that's what I do in my real life. In my real life job, I'm a software developer, and I work 99% with Windows machines. So I own. This is the first PC I've had in about 8 years. That's not to say I don't run Windows machines. I run on VMs. Because to me, the hardware for the Mac is just really solid, and I can run a VM and have the best of both worlds. I can run Linux, I can run Windows, and I can run Mac. Yep. And actually, I got this laptop to run my printers, and I also have a home-built CNC machine I made. And the CNC machine uses the software I use is only available on Linux. Whereas that's one real nice thing about the RepRap software. It's available on Windows, Linux, and Mac. For the most part, all of it's available on all three different platforms. So no matter what platform you use, you'll be able to print with it.
I can't think of the name of the machine, but it uses wire.
EDM.
EDM, thank you.
Yeah, EDM machine.
Has anybody made it, laid out the parts to make one?
It's funny you mention that. A friend of mine works in Beam Connectivity, and and he's a machinist, and he works with EDM machines, and he wants to build one of these so he can build an EDM machine using the parts off of this.
It runs from additive to subtractive.
Yes. I found that this, and this one technically is not a pure rep wrap machine, because these white pieces up here, I actually made those on my CNC machine. Because at the time, I didn't have access to a printer, and I'm like, well, that's simple enough, I can do that on the CNC. So, cranked it down the CNC. I did have to use a drill press to drill the side pieces, but it's been working fine.
You guys meet on Monday.
We meet, yeah, we
I
meet
make a motion to
officially.
move our club meeting.
We meet officially, we meet officially on Mondays and Thursdays, and like I said, Mondays are open house. Thursdays are the nights we're building printers, and this one is gonna eventually be the printer for the space. I'm donating this to our hackerspace, so there'll always be a 3D printer up there. And so if you're a member, you can come up and print anything you want whenever you need to. The space is open to members 24/7, and there's almost always some kind of class going on Mondays through Thursdays. Usually Tuesdays, they're doing some programming classes, but there'll be guys working on the printers there. So we're on Brookstown Avenue. If you go to fablocker.org,
You have the business and technology? Just above David Woodstone Avenue.
it's almost, you know where West End Cafe is? The door, the entrance is in the alley behind West End Cafe.
You have to have a secret knock, so. You're right about the-
Yeah, actually, we don't have a phone number up there. You need to put that back up. We usually kept a phone number on blue tape on the door, but we recently painted the door. So it looks real nice and clean, but no one can get in now except members. But generally, if you post on if you look on fablocker.org, we've got links to our wiki site and our Google groups. And you can join that for free, and anyone can join that. And you can see when people are gonna be up there. We'll post, hey, I'm gonna be up there Tuesday night working on this, working on my quadcopter, which Tim helped me with so kindly. Meetup.com, well, it's all on fablocker.org. We've got links to our Google groups, our Meetup page, our wiki, and other things we're involved in. We're also doing sessions on software development, and I'm going to be doing one next Wednesday at the Old Winston Social Club. It's just coincidence that they serve beer there. But I'll be doing a talk on test-driven development, and we have people that are just learning programming, and we have all sorts of people coming in there. We have musicians coming in there wanting to do some stuff in electronics. We had a class on building a contact mic about 2 weeks ago. So there's always different classes going on, not just for rep rap, but there's electronics, there's craft classes. And we recently contacted there's a new group starting up in Burlington, the Alamance Makers Guild, and they're definitely more oriented towards the craft side, woodworking, metalworking, blacksmithing. And looks like we're gonna establish a relationship with them, because we're more the electronics and geeky stuff, where they're doing a lot more of the craft stuff. And there's gonna be a mini maker fair at the, what's the name of the mall? Okay, Tim's gonna look at it. In the middle of April, and you can find that on Meetup as well. FABLOCKER.org or .com. Either one will take you to it.
You have a glass plate that looks like and something over the glass plate. What is-
Yes.
is that-
Let me give you a quick rundown of what the rep wrap is, and I'll show you everything about it, explain it real quick. Like I said, we've got these threaded rods give the structure to the printer. And then over here you can see we've got our controller board, which all the electronics plug into. I've got a power supply underneath, provides power for all the electronics and for the bed where things are printed. this printer bed is actually a piece of MDF on the bottom, and then we got a piece of cork for insulation, and then we have a circuit board that this has a bunch of traces on it. When we run 12 volts through it, it'll heat up. The plastic sticks much better to a hot surface, so that's why we have a heated build plate. And then on top of that, to make sure it's perfectly flat, we have a piece of regular glass. And the only problem with regular glass is ADS and PLA really don't like to stick with very well. So on top of that, we have a high temperature tape called Kapton or Polymide tape that the plastic will stick very well to. In fact, it can be kind of hard to peel it off. You have to let it cool off and get it as it's cooling off. For the PLA, a lot of times guys will use the blue painter's tape, and that gives it enough for the PLA to stick. So here we have the X carriage, and down on the bottom you can see the heated print nozzle. And then this right here is the extruder, which feeds the plastic into the nozzle and makes it come out. Over here we have the motor that moves the X carriage back and forth. On the top we have two motors connected to these threaded rods that move the X carriage up and down. And then in the front we have another stepper motor that moves the carriage back and forth, moves the printed object underneath. If there's no other questions, let's take a quick break, and then I'm going to start printing some stuff up here, and y'all can come up and take a look at it and ask me some other questions. This way.
Where can you learn with ham radio take you? Amateur radio, often called ham radio, is the place where today's communications engineers got their hands-on training. With its analog, digital, audio, and video capabilities, modern hams use computers and radios in new ways. It's not just your grandfather's radio anymore. It can take you around the world or into a whole new career. Learn more about modern ham radio at WeDoThatRadio.org.
With a 100 Hertz tone is located at the Baptist Hospital in Winston-Salem. On this repeater, we also have an Echolink node for access from other areas throughout the world on 2 meters. Stick around, our program will begin at 7:30 p.m. And thanks again for tuning in to W4NCLive.com.